Today's lesson is to be using units to convert between one set of numbers and a different set of numbers. So whenever you're converting, you need to have conversion factors. And typically we use what's called a railroad method. So the railroad track method looks like this. You have a line across, and we're going to put one thing on top of the fraction, and then the bottom goes here. And then we're going to just convert and convert and convert, and we're going to cross off units until we get to the units we want. So here it says that I have 4 meters, and I want to change it to kilometers. So we would put 4 and meters up on top. And then we need to know a conversion factor. Well, one of the things with conversion factors is you have to have them. So for metric, this is an example. You can Google this really quickly, but it's also provided for you. These are the prefixes. So anytime you see one of these prefixes, it's telling you how to convert it. So the way this works is your base unit, in this case it would be a meter, is sitting here and it's worth 1. If you have a decameter, a DAM, it's 10 times that. A hectometer is 100 times that, and a kilo, or a kilo, is worth 1,000 times that. So this is worth 1,000. So this is saying for every meter, I have 1,000 kilometers. And this goes on and up. And you should be familiar with some of these from computers. This is a kilobyte, megabyte, gigabyte, and 1,000 of those, 1,000 of those, terabytes. Next one that's going to be coming out would be a petabyte, which would be 1,000 terabytes. And it keeps going on up. Same thing happens when you go down, except it gets smaller. So from a meter to a decimeter, it's going to be 0.1 or a tenth. To a centimeter, it's a hundredth or 0.01. To a millimeter, the prefix milli is 1,000. And then it keeps going down. Micro, this is the symbol mu, is a thousandth of those. Then you have a nano, a pico, femto, and then an atto at the very end. So you can use these prefixes, and it doesn't have to be meters. You can use it with anything. So let's say that we want to have grams. So you have a gram and you want to get to a kilogram. It's 1,000 grams. That's how this works. You could also have a milligram, which is 1,000th of a gram. So there'd be 1,000 milligrams in 1 gram. So you can go up and down, and each of these steps is worth 10 until they have some jumps in here because they're skipping some, and those are worth 1,000. So use this prefix. It helps you a lot to know how to do it. And so we're going to use that one right here. So we want to go to kilometers or kilometers, as it probably should be called, even though it's not. So this is saying that for every meter, we have 1,000 kilometers, or for every kilometer, we have 1,000 meters. I said that backwards. Now notice the meters were on top, so I put the meters on the bottom. And the reason I did that is because we want the meters to cancel out. So we're going to cancel the meters out right now. And then I got to put numbers in here. So we know that 1 kilometer is worth 1,000 meters. That's what that other scale just said. So 1 kilometer is the same as 1,000 meters. Okay? And when I look at the last unit, I have kilometers here, and that's what I'm going for. So you just keep crossing things out until you get to the units you're looking for. Now, this is like fractions, so we multiply tops and we multiply denominators, and then we reduce. So on the top I have 4 times 1, which is 4. On the bottom I have, and if there's nothing here, there's a 1 there. So 1 times 1,000 is 1,000. And then if I reduce this, you're going to get 1 over 250. Okay, so it's 1/250th of a kilometer is what 4 meters is. The other way to do this is to put it as a decimal, and the decimal would be 0.004, 4 1,000ths. So tenths, hundredths, thousandths. So these are the same thing. And the nice thing about going from meters to kilometers is you actually don't have to go through this. I showed it to you because we're going to use it a lot of other times. But here's the deal. Whenever you have metric, like you do here, and you're just converting using the prefixes, you're just moving decimal places. So I start with a 4, and I can add as many zeros as I want after a decimal place. So 4 and 4.000 is the same. There's zeros out front here if you really want to. And if I'm going from meters to kilometers, it's getting smaller, so I'm going to move the decimal to the left. So I need to add some zeros over here as well. And this is 3 places because it's dividing by or multiplying by 1,000. So since the 1,000 was over here, we're going to move it to the left. 1, 2, 3, and that's now where the decimal goes. And if you notice, it's now 0.004, which is exactly what we came up with over here. So both cases you get 0.004. So you can use a shortcut if you want to use it. Make sure you remember which way to go because if it's getting smaller, it should go to the left. If it's getting larger, it should go to the right. Otherwise, you'll have a very unusual answer. If you're not, you can use the railroad method. So they both work exactly the same thing. With units, make sure that you are labeling them. The number is not enough. You must have the units as well. Otherwise, it's an absolutely meaningless number. So the answer here is not 0.004, but 0.004 kilometers, or km for kilometers. Okay? Now, when you have something like miles per hour to kilometers per hour, you're actually going to have to use a unit conversion. So we're going to start here with the railroad tracks. This is not metric, so we can't use the little trick over here. So we're going to start with 70 miles. And when it says miles per hour, that's miles. The per is divide, so hours are going to be on the bottom. So it says we go 70 miles in 1 hour. And we want the answers to be in kilometers per hour. So I already have the hours, but I need kilometers up here. So I need to get from miles to kilometers, and I'm going to need a unit conversion. Now I don't have one handy, so you can always Google it. So let's go ahead and Google it. So we want to know kilometers to miles. And if you have it backwards, you can switch it. So for every kilometer there's 0.62 miles. Okay, that's what our conversion says. So 1 kilometer is 0.621 miles. So we're going to go back to where we just were, and we're going to use that little information. So it's saying we want kilometers up here on the top, and miles on the bottom. And the reason we want miles on the bottom is because I want to cross those out, because I want the miles to go away and it's replaced with kilometers. So we now have kilometers on the top, hours on the bottom, which is what we need. And it said 1 kilometer was worth I forgot what it was. 0.621. So 0.621. Okay, and now we have kilometers over hours. So our answer is going to be in kilometers on the top and hours on the bottom. And now we're going to multiply. 7 times 1 is 70. And on the bottom, 1 times 0.612 is 621. And now you simply grab a calculator and you actually are going to do that division. So I'm going to do it really quickly on my calculator. And when I do 70 divided by 0.621, I get 112.7. So this is approximately 112.7 kilometers per hour. So if you're on the highway driving 70 miles an hour and you're at a country that uses kilometers, you'd be doing about 112 kilometers per hour. Now, there's no rule that says you only have to change one thing at the top. We can take this exact same one, instead of doing kilometers per hour, let's do it for meters per second. So we want to know what this is in meters per second. Okay, so we're going to take this and we're going to keep going. So right now I'm in kilometers per hour, but I don't want to be in kilometers per hour. I want to be in meters per second. So I need to convert again. So I have kilometers. Now I want to be in meters. So I have a conversion factor go from kilometers to meters. We know from up here that 1,000 meters is the same as 1 kilometer. So the kilometers now cancel, and I'm left with meters per hour. Well, I don't want hours, I want seconds. But I do know that there's a conversion from hours to minutes. I know that 1 hour is the same as 60 minutes. I'm going to just extend this. And so the hours now cancel. So now I'm in meters per minute. But I want seconds, but fortunately, I know that there's 1 minute is the same as 60 seconds. So I got 1 minute over 60 seconds. All right. So this is now, and the minutes are canceled. So we're now in meters on the top, and on the bottom we're in seconds. So this is meters per second, which is what I'm looking for. Now I got to multiply. I got 70 times 1 times 1,000 times 1 times 1. So that's going to be 70,000 on the top, because the 1 times 1 times 1 doesn't do anything. 7 times 1 is 7. I got 1, 2, 3, 4 zeros. So 70,000. On the bottom, we got 1 and a 1. Those go away. 60 times 60 is 3,600 times 0.621. So we got 3,600 times 0.621. And again, at this point, you need to use a calculator. I'm actually going to get it out to show you real quickly how to do it on the calculator. Where's my calculator at? There it is. because parentheses are really important on here to make sure you get them in the right spot. Otherwise, you've done all the good work and you're not going to get the right answer. So there's a couple ways to do it. One is you just get 70,000 on the top, actually multiply this first and get two answers, and then do the division. The other choice is to use parentheses. So as soon as this thing opens, which it's taking its sweet time on, I'll be glad to show you how to do that. So while it's opening up, let's talk about the next one, then I'll come back to this one and we'll evaluate it. Or maybe not. There we go. Coming up. Anytime now. Well, I'll give you a preview of the next one while we're waiting. It says, if an electronic device uses 60 joules of energy in 10 seconds, how much power did it consume in watts? So this is what we're going to do in the next question as soon as I finish evaluating it. And we're going to need to use this conversion factor. And that's what's going to show us how to solve this problem. All right, there's our software. So let's go back to this one and let's get an answer here. So first thing, we need a calculator. You can use Scratchpad, doesn't matter. And if you want to do this all at once, you're going to type in parentheses and then everything in the top, 70,000, parentheses, use the divide button, and then parentheses and then everything in the bottom. So 3600 times 0.621, close the parentheses, and hit enter. And it will have it in the right pattern, and it says our answer is 31.31. So this is 31.31. meters per second. Okay, so 31.31 meters per second. Now the other way to do it with your calculator is like this. They actually have a button over here. If you click on this, and this is the fraction button, and it will actually then set it up for you so you don't make the mistake of forgetting your parentheses, because now I don't need them, it's already done for you. Then on the bottom you're just going to type in 3600 times 0.621 and hit enter, and it will give you exactly the same number. So it doesn't really matter which way you do it, you'll get the same answer. So you just make sure that it looks the same as the way you set it up. If it doesn't, then you have a mistake somewhere. So make sure you're careful with this. Alright, let's get rid of that and we're going to answer this next question now. So the other thing you have access to is units. Now I gave you the units in here, but we have things like, there's some metric ones, there's science units. And it will give you stuff like this, and this is where I got it from. It says right here, 1 power is in watt, and a watt is the same as a joule per second. The J is joules. Okay, so joule per second. But all of these conversion factors are always here for you. So anytime you see a scale like this, it's telling you how to convert it. And we're going to use these a lot. So this is provided for you, or you can Google it really quickly. These are scientific units is what this is. Okay, but this one's given to you. So I know 1 watt is the same as 1 joule per second, because that's what I'm given. And I'm given joules, I'm given seconds. So it's telling me right here what the formula to solve this is. It says that if I divide joules by seconds, I'm going to get watts, and I want to know in watts. So we're going to do exactly what the formula says to do. So even though it's not technically a formula, this is units, it's acting like a formula. So I know that 1 watt is what I want, is the same as a joule per second. So if I put joules up here in the top and seconds on the bottom, I'm going to get watts out. So let's do that. Our joules were 60. And when I divide it by 10 seconds, I'm going to get 60 divided by 10 is 6 joules per second. But this is saying every time I have a joule per second, this right here is the same thing as 1 watt. Okay, so J over S and W are the same thing, so I get to exchange them. That's what this is saying. So this is first telling us how to solve it, and then it's telling you how to make it into watts. Okay, the other way to do this is to start with what you have, and you would have, if we did a railroad method, we'd have on the top 60 joules, and then on the bottom we're going to have 10 seconds, and there's nothing to convert because this is the same as a watt. So when we get rid of these, we could say that joules over seconds is the same as a watt, so those go away, and now we have the watts. Excuse me, this should have it reversed. But I think the easier method is to do it like this. So you can do it either way, but this is probably the simplest method, to use this as a formula, and it will tell you what to do. So let's say that I now know that I have a different electronic device, and it's using 300 joules, and we looked at it over 1 minute. Okay? So you know that I need to have joules per second. I don't have seconds, I have minutes. So the first thing I want to do is take minutes and change this into seconds, because this needs to be joules per second. So 1 minute is the same as 60 seconds. So I now have 300 joules used in 60 seconds. And when I divide those, you should get 5, because the zeros cancel. 3 divided by 6 is 5. So this is now 5 watts. Okay, so make sure you're looking at the units. It's joules and seconds. So I need joules on the top, seconds on the bottom. Divide it, you get out watts. All right, the last one, the most challenging one, is going to be something like this. So this one says, how much force in newtons is used to move a 1 kilogram wooden block at 3 feet per second for 5 seconds? Now, if we look back at the scientific units, we have this formula right here. Okay, it says 1 newton, I'm going to write it down for us. So we have 1 newton is the same as a kilogram times meter divided by second squared. So I need kilograms times meters over second squared. Okay, so let's get rid of this and look at this. So another way, second squared means seconds times seconds. So I have a kilogram times a meter over a second times a second. So this is what I'm looking for. So on the top I need kilograms and meters, on the bottom I need a pair of seconds. Here's what I am given. I am given that I have a 1 kilogram wooden block. Well, I need that on the top, so we're going to put it on the top. 1 kilogram. I am given that I have 3 feet per second. Well, that's similar to having meters, because feet and meters are both units of length, and I know a conversion factor from meters, feet to meters. So I'm going to put on the top the 3 feet, and it says 3 feet per second, so there's 1 second on the bottom. Okay, so I'm now trying to match these units, and I'm close. I have kilograms on the top. I have feet instead of meters, but I can change that. And I have 1 second on the bottom, but I need another second. Well, here's another second. So we're going to put on the bottom 5 seconds. So now if I multiply this out, we're going to be in kilograms, feet, and seconds times seconds. But I don't want feet. What I want is meters. So if I have feet on the bottom and meters on the top, so I can cross the feet out, now I have kilograms times meters over seconds times seconds, which is seconds squared, and that's the units I'm looking for. So I need the conversion factor to get from feet to minutes. So we're going to go ahead and look it up real quick. So feet to meters. And it says 1 foot is 30 meters. And you can always go the other way if you want. Doesn't really matter. So meters to feet. So you pick either one. Doesn't really matter. I'm going to use this one just to be different. So we got 1 meter is the same as 3 point. See, now it went backwards. 1 meter is the same as 3.28 feet. So I got 1 meter is 3.28 feet. So up here on the top we got 1 meter. Bottom we have 3.28 feet. And now I have kilograms on meters on the top, so that's gone. Seconds and seconds at the bottom, so that's gone. So our answer is now going to be in newtons. And now, just like before, we got to multiply the top. I got 1 times 3 times 1 is simply 3. And on the bottom, I got 1 times 5 times 3.28. So we got 5 times 3.28. I do not know what happened right there, so let's fix that real quick. 3.28, and now we're going to get the calculator out and we're going to go multiply that again. So we got this is in the wrong spot to do this. There we go. We're going to do 3 divided by parentheses 5 times 3.28, close the parentheses, hit enter, check, make sure it looks right. It does look right. So our answer is 0.18. So 0.18 newtons. Okay? So if you have questions, let me know, but this is going to take some practice. This skill is exceedingly important in science. As you can see, a lot of our examples come here from science. So not only do you need to know this for math, and it will be important on the SAT, but it will be critically important in science when you take either chemistry, physical science, or physics. So please make sure you spend some time on this and ask lots of questions until you get good at it, because you will be using this over and over and over and over again in the high school.